I'm going to discuss about the knapsack problem using branch and bound technique. Branch and bound is a systematic method for solving optimization problems that applies where the greedy method and dynamic programming fail. Also, we can say that the branch and bound is a powerful technique which reduces the search and gives us the bound. Let's enter into the problem now. So here we are just going to solve the knapsack problem using the branch and bound technique. So knapsack problem is about filling the knapsack with n number of items, and each item will be associated with the profit as well as the weight. The objective is to achieve the maximum profit subjected to the constraint of the capacity of the knapsack. So here the very first step which we are supposed to do here is calculating the upper bound. For calculating the upper bound, we are just going to follow the fractional knapsack concept. Why? Because the fractional knapsack gives us the maximum possible upper bound. Right? So for calculating the upper bound, the very first step which we are supposed to do here is identifying the profit by weight ratio for each items. So here I have done the profit by weight ratio for each item. For all the 4 items I have done. For item number 1, the profit by weight ratio which I have received is 5, and for item number 2 it is 4, and for item number 3 it is 5, and for item number 4 it is 5. And the maximum weight, the maximum capacity the knapsack can hold is 12. You can assume like it is 12 kg, right? So profit by weight ratio is identified now, and also again in fractional knapsack, after identifying the profit by weight ratio, what we used to do means like we'll be just arranging the items based on the profit by weight ratio in the descending order. Yes, I have done it. Based on the profit by weight ratio, I have arranged all the items in the ascending order. Now we can start calculating the upper bound. The maximum capacity given here is 12 kg. So we need to ensure that it is not exceeding the 12 kg. It is not exceeding the capacity given here. Right? So already we have arranged the items in the descending order. So if we consider the first item for calculating the upper bound, if we consider the first item, the profit which I could get is 10, and inside the knapsack 2 kgs will be filled. And after considering the second item, I will get extra 20 profit, and extra 4 kgs also can be filled inside the bag. So total there will be 6 kgs inside the bag. So 6 more kgs can be filled more inside the bag now, because total capacity is 12 kg. After considering the third item, the profit which I could get is 25, and the weight is 5. So 6 plus 5 only 11. So 1 more kg is required because the maximum capacity given here is 12. So it means it can hold up to 12 kg of the item, 12 kgs of the item. So here up to 11 kgs we have filled already. So 1 more kg is required. So according to the fractional knapsack concept, the fractional portion of the items can be considered here. So there is only one item is remaining, that is 3 kg, but out of 3 only 1 kg we are just going to fetch here. So 1 by, it can be written like this, 1 by 3 into 12. So we get 4. So the profit which I could get is 4, and the item which I could get is 1 kg. So total 12 kg is filled now, and the maximum profit can be received is 10 plus 20 plus 25 plus 4, it is 59. So the maximum profit which I could receive here is 59 using these 4 items, right? So the upper bound value here will be 59 now. So we have identified the upper bound value. Now we are just going to start exploring the tree, exploring the state space tree. So using branch and bound technique, we are just going to identify what all the items can be considered to achieve the maximum profit. So every time after exploring each and every node, we need to ensure that it is not exceeding the limit which is given here, exceeding the capacity which has been given here in the problem, right? So initially, without considering any of the item, what will be the profit? The profit will be 0, weight also will be 0, and the upper bound which we have received is 59. So the upper bound is 59. It means the maximum profit which can be received using these 4 items is 59. So without considering any of the item, the profit will be 0 as well as the weight also will be 0. You can name this node. We will name each and every node. So this is our very first node, node A it is. So without considering any of the item, the profit is going to be 0, weight is going to be 0, upper bound is going to be 59. Now we are just going to start considering the items one by one. Now if you consider the first item, so what is our first item? So to stop scrolling up each time, I will Write the question one more time here. Profit and weight. So profit is 10, 12, 20 and 25, and weight for each item is 2, 3, 4 and 5. This is the problem. We'll start considering the items one by one. So if I consider the first item, the profit will be 10, weight will be 2, the upper bound will remain same because we have, while computing the upper bound, we have considered the first item, so there is no change. If you consider the item, there won't be any change in the upper bound. When you don't consider the item, there will be the change in the upper bound. So if you don't consider the first item, this is node B. We are going to write node C now. So if I don't consider the first item, profit will be 0 only, weight also will be 0 only, but upper bound will not be 59. Why? Because we are going to exclude the item number 1 here, but when we compute the upper bound 59, we have included the item number 1. So now what will be the upper bound value when you exclude item number 1? So for C, upper bound will be, we are going to exclude the item number 1, right? So you should not consider item number 1. Now I am just going to consider item number 2. If I consider item number 2, the profit which I will receive is 12, and second item will be 20, and third item will be 25. If you check the weight, 3, 4 and 5, it is just 12. So every time when you compute the upper bound newly, you just ensure that it is not exceeding the weight. So when I check, it is only 12 only. So now excluding the item number 1, the upper bound which we can receive here is 12 plus 20 plus 25, it is 57. So excluding item number 1, the upper bound value is 57. Now only these two nodes are live now. Which node to explore first? Check the upper bound. Which node has maximum upper bound? You need to start from that node. So the node B has maximum upper bound, so we will start exploring node B. Now considering the first item, we have given the profit, weight as well as the upper bound. Now start considering the second item, include the second item as well as exclude the second item now. So if I include the second item, what will be the profit? Already the profit was 10. After including the second item, the profit will become 22. Already weight was 2. After including the second item, 2 plus 3, the weight will become 5, and upper bound will remain same, that is 59, because while computing the upper bound, we have included the second item as well. So always when you consider the item, there won't be any change in the upper bound. When you don't consider the item, there will be a change in the upper bound, right? So even when you don't want to consider the item number 2, it will remain same. Profit will remain same, that is 10. Weight also will remain same, that is 2, but there will be a change in the upper bound because we have considered the first item, but we don't want to consider the second item. So this is node C and this is node D. So for node D, what will be the upper bound value? We'll write here. Node D means what? Including the first item and excluding the second item, right? So when you include the first item, the profit which we'll receive is 10 and the capacity is 2 kg. We need to exclude the second item, and third item can be included, so the profit is 20 and the weight is 4, and fourth item also can be included, profit is 25 and the weight is 5, right? So when you check the capacity, only 5 plus 4 plus 2, it is 11. So it is not exceeding the maximum capacity, and the upper bound value is 20 plus 25 plus 10, it is 55. So excluding item number 2, the upper bound value is 55. Right. So now there are 3 nodes are live, upper bound D, C as well as, this is D and this is E. So 3 nodes are live now, node C, node D as well as node E. So when you check all these 3 live nodes, you just pick the node which has the highest upper bound value. Yes, the node D has highest value, upper bound value, so we'll start exploring the node D now. Now considering the first item is over, second item is also over. Now including the third item and excluding the third item. When I include the third item, so what is the weight of the third item? It is 20, sorry, weight is 4 and the profit is 20. So already profit 22 was there, and 22 plus 20, it is 42. Yeah, profit will become 42. Weight already there was 5 plus, after considering the third item weight is 4. So 4 plus 5, it will be 9, and upper bound will be as it is, that is 59. If we consider the third item, node F it is. Now excluding the third item, now profit will be as it is, that is 22. Weight also will be as it is, that is 5, because we don't want to include the third item, and the upper bound value will be for node G. So when you exclude, there will be change in the upper bound. So you want to include the first item, second item, but third item alone you want to exclude. So second item profit is 12, weight is 2, and here weight is 3. So I want to exclude the third item, and fourth item is 25 and the weight is 5. So when I check the total capacity, it is only 10, it is not exceeding the maximum capacity, and the upper bound value is 10 plus 12 plus 25, it is 47. So the upper bound value excluding the third item is 47. So now totally there are 4 nodes are live, F, G, E and C. When you check all these 4 nodes, the node F has the greatest upper bound value. So you start from the node F. Now one more item is remaining. So if you include the fourth item and if you exclude the fourth item, what will be the upper bound? We are going to check profit, weight as well as the upper bound. So when I include the fourth item as well, the fourth item's profit is 25 and the weight is 5. So already the profit 42 was there. If I include the 42 plus 25, I will get 67. When I check weight, already there is weight 9 is there. After including the fourth item, the weight of the fourth item is 5. So 5 plus 9, it will be 14. But when I check the maximum capacity, it is only 12 here. So the maximum capacity given here is only 12. So now if I follow this path, if I if I include the fourth item as well, the weight which I will get is 14. So which is exceeding the weight limit given here. So this node can't be explored, right? So you just go with the next option, that is excluding the fourth node. If I exclude, profit will be as it is 42, weight will be 9 and the upper bound value will be, we are supposed to calculate. This node name is H. For node H, we are going to compute the upper bound value, means excluding the fourth item. So first item is 10 and the weight is 2, and the second item is 12 and the weight is 3, and third item is 20, the weight is 4. So the upper bound, when we check 5 and 4, that is only 9, not exceeding the maximum capacity, and the upper bound value is 42. So if we exclude the fourth item, the upper bound value which we can receive is 42, right? So now you just check all the live nodes. The live nodes are C, E, G and H. So out of these 4, you just find out the node which has the greatest upper bound value. So since the node C has the greatest upper bound value, we are just going to start exploring the node C now, right? So exclude the first item. In excluding the first item is over. Now you start including the first item here, as well as you start excluding the including the second item, as well as start excluding the second item here, right? So if I include the second item, what will be the profit? Check the second item. Second item profit was 12. Already the profit 0 is here. 0 plus 12, it will be 12. Weight also was 0. After including the second item, the weight will become 3, and the upper bound value, what will be the upper bound value? Excluding the first item. So excluding the first item and including the second item. Yes, so when we calculate this upper bound 57, we have excluded the first item as well as we have included the second item. So there won't be any change in the upper bound value. As I told you before, when you want to include the item, there will not be any change in the upper bound value, because while calculating the upper bound, definitely we would have included that particular item. So there won't be any change in the upper bound value when you want to include the item. So when you want to exclude only, there will be a change in the upper bound. So if you include the second item, the profit will be excluding the first item, and including the second item, the profit will be 12, weight will be 3, and the upper bound will be 57. And you can name this node as I, excluding the second item. So when you exclude the second item, profit will be as it is, weight will be as it is, but upper bound value we are supposed to calculate. We'll name this node as J. So for node J, we are supposed to calculate the upper bound value. So when you check the node J, first item also not considered, second item also we don't want to consider. So first and second item we are excluding. Third item, profit is 20, weight is 4, and fourth item, profit is 25, weight is 5. So the maximum upper bound value which you could get excluding the first item and second item is 45, and weight, if you check 9, which is not exceeding the maximum limit given here. So excluding the first item as well as the second item, the upper bound value is 45. Now what all the nodes are live now? Node H, node G, node E, I and J. So out of all these nodes, you just pick the node which has the greatest upper bound value. Yes, the node I has the greatest upper bound value. So you start exploring this node. Now considering the first item is over, second is also over. Now include and exclude the third item now. When you include the third item, the profit will be, already profit 12 was there. After including the third item, the profit will become 32. Weight will become, already weight was 3. After including the third item, weight will become 7, and upper bound value will be 57 only. Why? Because while calculating this upper bound 57, we have included the third item as well. So there won't be any change in the upper bound value. Now when you don't want to consider the third item, profit will be as it is, that is 12, weight will be as it is, that is 3, and when it comes to upper bound value, like different upper bound value will be getting, excluding the item number 3. So excluding item 0, including item 2, excluding item 1, including item 2, excluding item 3. So the node, this is K and this node name is L. So for node L, we are going to compute the upper bound. So when you check the path, when you check the flow, excluded the first, included the second, right? So included the second. So when you include second, the profit will be 12, weight will be 3, also excluding the third. And fourth item, profit is 25 and weight is 5. So when you check the capacity, it is only 8, which is not excluding the maximum limit. And the profit, the maximum profit which we could get here is 37. Right, now again we are just going to check the live nodes, all the live nodes. So the live nodes are E, G, H, K, L and J. Out of all these nodes, again the node K has the greatest upper bound value. So we start exploring the node K, including item 4, excluding item 4. If you include item 4, the item 4 profit is 25 and weight is 5. So 32 plus 25, it will be 57, and weight will be 12. Already there was 7 and plus 5, the item 4's weight is 5. So weight will become 12 and upper bound value will be as it is, that is 57. Right, excluding item 4. Profit will be as it is, that is 32. Weight will be 7 and upper bound value will be we have to compute. So when you check the flow, including the item 1, excluding item 0, including item 2, including item 3 and excluding item 4, will compute here. For node N, when you check the flow, first item is not considered, second item is considered. So if you consider the second item, the profit is 12, weight is 3, and third item is also considered. So third item weight is 20 and profit is 20 and the weight is 4, and fourth item is not considered, so 0 and 0, 7 which is not exceeding the limit, so 12 plus 20 it will be 32, right? So now we are supposed to identify the live nodes now. So what are the live nodes? H is the live node, M, N, G is also the live node, E is also the live node, and J is also live node. These are all the live nodes. Out of all these live nodes, you need to pick the node which has the greatest upper bound. Yes, the node M has the greatest upper bound, right? So when you start exploring the node M, since there are only 4 items are there are no more items to consider here, so you can't explore the item M. As well as when you check the weight, it is maximum capacity which we have reached the maximum capacity which has been specified in the problem, that is 12. Yes, we have achieved the weight 12 and the maximum profit which we could get is 57, right? So when you check the path, this is the flow, excluding the first item, right? I'll write the solution here. Excluding the first item and included the second item. Yes, we have included the second item. Also we have included the third item. Yes, we have included the third item. Also we have included the fourth item. So this is the solution vector. Excluding item number 1, including all the remaining items, item number 2, 3 and 4, we are able to achieve the maximum profit 57. Also we are able to fill the 12 kgs inside the knapsack, which is equal to the maximum capacity given here. So this is how we are supposed to explore the tree, the state space tree. Always when you want to explore the node, only the node which has the greatest upper bound we are supposed to explore. Thank you. This is the solution vector.